iron will corrode, or will rather do what? Rust in the presence of water and air. But platinum doesn't rust. But platinum, corrosion of iron is also called rusting. So the next question says, platinum acts as a catalyst. State in terms of its position in the periodic table why you would expect platinum. Welcome to Sir Majesty Easy World Science channel. If you have not subscribed to my channel, please endeavor to do so. I beg of you, subscribe and share this video. Expand this science. I'll be handling the GCSE past questions, past papers, the solutions, and also this is applicable to IGCSE. Today we'll be taking a look at chemistry 2019 past papers, and then check for other years on this channel. So the candidate's name here should automatically be Sir Majesty. So let's fill our name. Easy World. Science channel. Then the candidates and the center number should be please subscribe. For more, as you subscribe, you also share this video. Remember to ask your questions in the comment box. So look at the instructions given, it's obvious, you read them well. Then we go down. The first question says, in a hydrogen oxygen fuel cell, hydrogen and oxygen react at the electrodes. The overall reaction occurring in this fuel cell is a reaction of hydrogen with oxygen. Write the balanced equation for this reaction. So simple, they have mentioned the reactants. You're going to write H2, which is gas, plus O2, which is also a gas, to give you H2O. That's the overall reaction. Then you need to balance the chemical equation. You're going to put 2 behind water, or rather in front of water, then 2 in front of oxygen, in front of hydrogen, and you are finished with that. Then the B part of it says the electrodes of a fuel cell are in contact with water and air. The electrodes are made of platinum rather than iron. State why iron is not suitable metal for the electrodes of the cell. Look at the statement. The statement says that the electrodes are in contact with water and air, and these are the 2 conditions necessary for iron to rust. So the reason why iron is not suitable is that reason is because iron will corrode, or will rather do what? Rust in the presence of water and air. But platinum resists, doesn't rust. But platinum will not rust, or doesn't rust. Will not rust. Be as precise as possible. You can say because platinum is resistant to corrosion, because corrosion of iron is also called rusting. So the next question says, platinum acts as a catalyst. State in terms of its position in the periodic table why you would expect platinum to act as a catalyst. The position is because the position in terms of states why in position, because platinum is in D block, because platinum is a transition element, is among the D block bracket the what? Transition elements. Either I'm gonna remove this, among the D block stroke the transition metals which have catalytic activity, which possesses catalytic activity. Remember, the transition elements are the ones found in the D block of the periodic table, and they themselves are used as catalysts because one of the reasons is that they are capable of showing a variable oxidation states, and therefore their compounds can also be used as catalysts in most reactions. Like in Haber process, the catalyst used there is finely divided iron. So in that of there are many other processes. Even in the Ostewart process, you use the vanadium or the rhodium. Even in the contact process, vanadium 5 oxide is the catalyst. So nickel, all these are all transition elements. And I got to lift the table a bit to show you the position of what we mean by transition elements. It has the D block in the periodic table. So I'll use the majestic periodic table I designed myself. You can also place order that this table can be shipped to you anywhere you are. Here is the table. So we'll be needing the highlighter maybe to do justice to that. So we're gonna put this in this mode and then use this. Okay, so over here I guess my highlight is needed, is visible either. So that's the transition, is well labeled there, transition, and you can see that platinum is there. If you check the position of the platinum, here is platinum. See it over here. So the transition elements are the D block elements. We have the 4 block, the P, the D, F, and S. In the correct order should be S, P, D, F. But the D block elements are usually, they have the catalytic ability. They are transition elements, and we say they have variable oxidation state. They have partially filled d orbital. So that's very clear. So you can place order for this majestic periodic table. It has other unique features. See, it contains the electronic configuration of all the elements, also have the half bow, the order of filling of the orbitals, the maximum electrons. I'll still include the shapes of the orbitals. So the artificial elements, the radioactive elements, the staircase, as you can see over here, which divides the elements in the periodic table into 3 metals, metalloids, and non-metals. So amazingly, there are other basic facts you need to know about them. You can print them to any size. This one is actually not a direct file, but is available for sale. If you need the soft copy or the hard copy, you indicate. So let's go back to our questions as we continue. Remember, you're on with Her Majesty Easy World, of course. Then we move on to the next question. They say some metal objects are electroplated. State 2 reasons for electroplating a metal object. Why do we electroplate a metal object? Reason is actually, electroplating is what first? Electroplating is the covering or the coating of the surface of a metal by another metal that is more shiny in order to protect it mainly from corrosion. So there are, from this definition, one can infer 2 reasons. One is to protect the metal from rusting or corrosion. Second is to make it more shiny, that's to improve on the appearance of the metal. So you fill in here, to protect the metal from corrosion. Then secondly is to improve on the appearance. Like iron is used to make spoons, but you can't use iron without electroplating it because it will rust. Imagine, will you eat with rusted spoon? No. Therefore, we have to coat such spoon with silver, and we now call it silver spoon, but it's actually an iron coated with silver. So you are going to improve on the appearance, to improve on the appearance of the metal. So these are the 2 major reasons why we electroplate. Like commonly, in the earlier roofing sheet that was used in building was actually iron, but iron is very much prone to corrosion, and the iron oxide formed is never protective, unlike some oxides of some metal like aluminum oxide is actually protective, but iron oxide, iron 3 oxide, is not. So to prevent iron from rusting, it is now coated with zinc, and that is what we used as a roofing sheet. Remember, coating anything with zinc, we call it galvanizing, and you can achieve this by anodizing, or what we call sacrificial anodizing. Remember that you can still contact me for further learning with the number you see here, +234 7065 166 217. I have many students I've trained in this GCSE. They do well, and equally the IGCSE here. So just make your contact. We start off.
Wait a minute. Have you heard about Sir Majesty Easy Word? Well, I'm a subscriber to at Sir Majesty Easy Word on YouTube, and I'm a student at University of Camerino, Italy. Sir Majesty made science so easy for me, and it took away the fear I had on chemistry and biology. Distance is not the barrier. Guys, you have to join the Easy Word today at www.easywordscience.com and on YouTube at Sir Majesty Easy Word. Bye. Thank me later.
So we go to the next one. This is very nice. This has come to the periodic table that I showed you. So question number 2 is giving us the periodic table, a kind of a sketch of the periodic table. Now, for us to answer these questions, well, I got to go back to that table again to help you understand more. This table have 4 blocks. So over here is the S block, here is the P block. So over here you can see it, P block, this is the S block, and then this is the D block, and finally the F block. Then all the S block elements are metals except hydrogen. Hydrogen is an intermediate, is a non-metal actually, but because of its structure it is placed in group 1, not because of its chemical property, because it has just one valence electron. That's why some authority might lift it. As you can see, I did it here also, to be on its own, though this was lifted to explain the details in each box. So some authority might decide to place it in between, okay, not in any of them. So you can see the 4 blocks. I say the S block elements are all metals except hydrogen is a non-metal. It has more property closer to halogen, so it is an element that have a dual property. That is for hydrogen. Then the D block elements, the D block elements are purely metals, so you call them transition metals or transition elements. Then coming to P, it is in this P block, which includes this bar, this bar, this bar, this bar, this bar, at least 6 groups there. So it is only this P that have mixture of metal, non-metal, metalloids, but mainly the major thing there are actually non-metal. So the one shaded in blue are metalloids, then the one in silver are actually metals. That's why we call them the P block metals. Over here, the P block, aluminium, the indium, tin, lead, these are all metal. Polonium is a metal. Then, but fluorine, chlorine, the halogens are all non-metal. Oxygen. So we have the P block having both the metal, the non-metal, and metalloids. So if you are looking for a non-metal, you look for it at the P block. Then for F block are also metals. So you see that more than 50, more than 60, equally more than 70% of the chemical elements we have are metallic. So we have lesser non-metals than the metallic element. Up to 80% are actually metals. So, and with this, we'll be able to answer those questions they gave us. Let's go back. Okay, the question have given these things, they gave it to us in letters. If you check here, they made it, this is group 1, 2, then 2, 3, 4, 5, 6, 7, and 0. This group 0 can be called group 8. Remember, this is the oxygen, the hydrogen we talked about, but they placed it in the middle like I told you because it cannot suit well as group 1 because of its chemical property, but structurally it can be in group 1, but chemically it should be a halogen. So that means this is our alkali metals. This is the S block. Group 1 and 2 are S block. Then 3, 4, 5 to 0 are the P block. Then here automatically is the D block element, which is Z. The letter Z is for transition element. So, and remember that this is going to be period, automatically this is period 1, 2, 3, 4, 5, 6. We have 7 periods. The other periods are not shown here. But remember that here is also period 2 and not period 1, because this is the direction of period 1. What should have been here is, which is this hydrogen that was lifted. So period 3, 4, 5, and still 6. So we now go to the question immediately, which says, using the letters A, E, G, J, X, and Z, give the letters of the two elements that are non-metals. Remember, I told you that non-metals are found in the what? P block. We can't find non-metal in the S except that of hydrogen. So, but they didn't put it there. They removed hydrogen and placed it in the middle. So, in that case, I have to still clean off this so that I will leave the original table and explain more. Okay, this is the original table. I'll use the highlighter here. Okay, I've not finished cleaning. Let's clean off all this. Okay, then this is the table. The question says the one that they are asking us for two elements that are non-metals. So you will not look at them in this S block. You will not look for non-metal in D block. Rather, you will look for non-metals in this P block, of course. So in that case, we have that E, G, X are correct. If you say E, X, or G, this is E, sorry, G or X is correct. You mention any of them. So we come here and fill. They just say give two letters that represents non-metallic elements. So we might use, we can say here E and G, since they say two. Or you can say G and X. Yeah, or you can equally say E and X. So any of these pairs are correct. Then the next question says, give the letters of two elements in period 2. Give the letters of two elements in period 2. Remember, this is period 1, while here is period 2. Periods are actually horizontal rows that contains elements whose atoms have equal number of shells. That contains elements whose atoms have equal number of what? Shell. Meaning, if we have element that have two shells, that's two circles, you place them in group 2. But when they have 3 shells, you place them in group 3. So this is our group 2. Period 2, period 3, 4, 5, 6. Like I said earlier, they are now asking us for elements in period 2. If you look where there are 3 elements in period 2, which are elements A, E, and G. So you can use any of them, elements A, E, and G. You can say the element A and G, or you say E and G. They are all in period 2. That's it. Then we move on. Give the letters of an element that normally forms an ion with a charge of +1. Elements that usually form ion with a charge of +1. Group 1 elements forms the charge of +1. That is the alkali metals. The alkali metals are actually the group 1 elements. They all form charge of +1. It's very simple. The alkali metals, that's what we call the group 1 elements. They all form a charge of +1, including hydrogen actually. So you can pick any one. If you look at there, we have elements A and J. They are all in group 1. Elements A and J are in group 1. So you can write the 2 here. They say give the letter of an element, any element. You can write A or J. That settles it. Now, element E has an atomic number of 5. In a sample of E, there are 2 isotopes. One isotope has a mass number of 10 and the other isotope has a mass number of 11. Explain in terms of subatomic particles what is meant by the term isotopes. this is just trying to tell you, you have to define isotopes here, and then they say explain in terms of what is meant by the term isotope. You just define isotopes. So you say isotopes are atoms of the same element. Atoms of the same element with the same proton number or the same atomic number. If you don't call it proton number, you call it atomic number, but with different mass numbers or with different neutron numbers. So that is one way you can define it. Or you say isotopes are atoms of the same element with the same atomic number but different mass number, or atoms of the same element with the same proton number but different neutron number. So you can say but with different mass number, or you say different neutron numbers. That doesn't mean that another name for mass number is neutron numbers, please. No. Mass number is the number of neutrons and protons, but atomic number is the number of protons only in the nucleus of an atom. So another name for proton number is atomic number, but another name for mass number is no neutron number. Rather, you can call it nucleon number. Nucleon meaning both proton and neutron is what we call the nucleons. Okay? So this is it. Then we move over. This one says all atoms of element E in this sample contain all atoms of element E in this sample contain A 5 protons, B 5 neutrons, C 6 protons, D is 6 neutrons. You go back to the statement. They made it clear there that the atomic number is 5, and I've told you that atomic number means the number of protons only. Remember, for a neutral atom, take note, atomic number is also the number of electrons. For example, if I write sodium and put 11 here, this is neutral because there is no charge. I didn't add plus or minus. Therefore, the proton number here is 11, electron number here is also 11. But when there is a charge attached, you can no longer define atomic number as the number of electrons. I know this might be confusing. Let me take it again. If you are told to define atomic number, you say atomic number is the number of protons in the nucleus of an atom only. Or you can equally say the atomic number of a neutral atom, you must put neutral, is equal to the number of electrons. You are very correct. But here, this one with charge is no more neutral. Proton number remains 11, but electron is automatically 10. Do negative counting. If you see plus, you minus. This is plus 1. You just say 11 minus 1. But let's assume there is Na minus. I would rather now say the number of electrons will now be 12, because I'll say 11 plus 1. So if you see minus, you add. If you see plus, you minus. You subtract. That's how to know electron number present in a charged ion. Then element X, we're going to the C part of it. Element X, so we will shade this. A is the correct answer. Element X has an atomic number of 18. State the electronic configuration of an atom of X. So they said it has an atomic number of 18. I've told you that means the electronic configuration will be 288. That's it. Depends for shell, 288. Or rather, you can equally use 1s2, 2s2, 2p6. We have distributed 10, then 3s2, and that's 12 for you. Then 3p6, which is 18. And this is actually for argon. Argon. In an experiment, 3.5 grams of element A reacted with 4.0 gram of element G. I'm going to question D. To form a compound, calculate the empirical formula of this compound. The relative atomic masses of elements A and G is 7 and 16 respectively. So you must show your workings. Here you have to endeavor to get the marks. So since they say show your workings, you write simple elements mentioned. You describe, use the term, they called it A and B. If they have C, you include it. Then the next thing you have to write is, you write the composition by mass. Composition by mass. Show that. You can possibly, if you have access to it, let's use our ruler to have a neat work. Yeah. Okay. Okay. Then the next thing is we still rule more since we have started ruling. Use the ruler wisely. Okay. Take it up there. After the elements, then composition by mass. Then you now say atomic, relative atomic masses. You state the relative atomic masses of the elements. Okay. Though the line is already there. The next is the relative atomic masses of elements. It gave it to us. A is 7, but let us fill the composition by mass. An experiment 3.5 gram is for A, is in the question. They gave it, as you can see there. That's 3.5. Then element G. Okay, this is G and not B. Don't mind me, please. It's G. Solve in terms of G, not B. Element G, the composition by mass is 4.0 grams. Then the relative atomic masses that was given to us is that A is 7. Automatically A should be 7. And then here is 16. The next thing you're going to do is divide composition by mass by the relative atomic mass. So you get to have the mole ratios. To get the mole ratios, you have to divide the mass given all over relative atomic mass of each element. Therefore, we have 3.5 over 7, going by our calculator over here. So we have 3.5 over 7 is 0.5. So that's half. 0.5. Then the next is 4 divided by 16, which is automatically 1 over 4, which is 0.25. Well, let's use our calculator still. So 4 divided by 16 is 0.25. So this will give us 0.25. Then you divide by the smallest ratio. So the next, to get the empirical formula. Remember, empirical formula is the simplest formula of a compound. So you divide by the smallest ratio. For us to divide by the smallest ratio, we have that dividing by the smallest ratio among 0.5 and 0.2, which one is smaller? 0.2 is smaller. Therefore, we're going to divide 0.5 divide by 0.25, which will give you kind of 2. Then 0.25 divided by 0.25. This is 1, and this should be 2. But let's press to convince you. We have that 0.5 divided by 0.25 is 2. So we have 2 here and have 1 here. Therefore, the empirical formula of this compound is under A, our answer was 2. We write A2. Under G, we got 1. We just write G. So the empirical formula is A2G. Remember, if you say G1, it doesn't make sense. In science, we don't write 1x, we just write x, such that the coefficient of x is already 1. So we cannot write G1 in this way. So it is A2G, that is the formula, the empirical formula of the compound. If they have given us relative molecular mass of the compound, we will now calculate for the molecular formula. Okay, then the next question says water, acidified with sulfuric acid is decomposed by electrolysis. The water is decomposed to produce hydrogen and oxygen. A sample of hydrogen is mixed with air and ignited. State what would happen. What will happen? This is just test for hydrogen gas. If you mix the hydrogen is mixed with air, so mixture of hydrogen and air burns explosively, that is, it burns with a pop sound. So state what will happen. You say it will burn with a pop sound, because they didn't tell you to state reason actually, but the reason is because mixture of what? Mixture of hydrogen and air burns explosively, just like because of the oxygen, explosively. So remember, if you mix hydrogen and oxygen and ignite it, we call it detonation gas, it will explode very well. The constituent of the air that makes it burn explosively is actually because of the oxygen. So even if you don't mix it with air and mix with pure oxygen and then ignite it, it will still burn explosively. But pure hydrogen burns quietly without producing enough explosion with a pale blue flame. This is actually test for hydrogen gas. You can watch the video here on Sir Majesty Easy World, how to test for gases, oxygen, to test for oxygen, test for hydrogen. They are all available here at Sir Majesty Easy World. Okay, this question says, throughout the experiment, the volume of hydrogen and volume of oxygen are measured at 2 minutes interval. The results are shown in figure 2. In this figure 2, at 0 minutes, there was 0 cm3 of hydrogen, 0 cm3 of oxygen. Follow the table. After the first 2 minutes, we have 4 cm3 of hydrogen, then 2 cm3 of oxygen. If you take a look at ratio 4:2, after the next second 2 minutes, which is after 4 minutes, the ratio is 8:4. Taking it further, the ratio is also 2:6. Then again 16:8. At the end, the ratio 4:2 is the same thing, divide by the lowest of them. If you divide all of them, they are all giving us 2:1, 2:1, 2:1, 2:1. So it shows, describe using the data in figure 2 what the results show about the volumes of hydrogen and oxygen produced in this experiment. Simple, it shows that the ratio of the volume of oxygen, it shows that the volume of hydrogen to oxygen is always in the ratio of 2:1. Remember, they are just trying to prove this formula, which is H2O, and the apparatus used to conduct this experiment is actually the Hoffman voltmeter, though they didn't ask us that. The Hoffman voltmeter, we might come across them when we treat further questions. So I think we will end this section to continue in another part. Please endeavor to do what? Subscribe and then share this video to get to others, and contact me for further learning with +234 7065 166 217, or you might indicate in the comment box Thank you for watching. Thank you so much. Remain blessed. Best of luck in your IGCSE and also in your GCSE. I handle chemistry, biology also, and other sciences. We have capable hands to handle you well.
Wait a minute. Have you heard about the Majestic Table? It was designed and recommended by Her Majesty himself. Here it is. The amazing thing about the Majestic Periodic Table is that it provides a clear and colorful classification of elements from P block metals to metalloids to liquid metals. It also shows the boiling and melting points of all the elements. It also has the unique feeling of electrons in the shells of each element.